Little Mathematics Library. So some of you may know that mere publishers published many books like this called a Little Mathematics Library. So where there are theorems and some small topics are covered in small books. So this is the usually these books are less than 100 pages, as you can see. So this book is Gödel's Incompleteness Theorem by Uspensky. So this book was published in 1987. So what about the contents? So there's an interesting statement in the preface, so I'll go through that. Before that, first they have the what is the incompleteness theorem, so statement of the problem. Then the simplest incompleteness criteria. So theorem and everything, 3 exams for the theory of algorithms. It all goes up to 32. After that, appendixes starts from page around page 40. So, and finally, part F, we have exercises for sections and appendix. Finally, we have answers and hints for the exercises. So, in the preface, I'll read through it. It's a bit interesting. So, this is what the author says. There are some topics in mathematics which, though enjoying a certain fame, have traditionally been considered either too complicated or of insufficient importance to be included in the core mathematical curriculum. Customarily, such subjects are relegated to optional units of the syllabus, independent study projects, seminar papers, and math club talks. Among such topics are several which remain in this nebulous status only because of inertia. An example is Gödel's incompleteness theorem. Although very many mathematicians and non-mathematicians have heard of Gödel's theorem, very few could explain exactly what the theorem says, let alone how it is proved. Yet the result is so important, and the reasons for the fundamental incompleteness, that is the impossibility of ever attaining a situation in which every true statement can be proved, are so simple that Gödel's theorem can be taught to first-year college students. Moreover, the only prerequisites for understanding the proof are familiarity with the terminology of set theory, the word sets, function, domain of definition, and the like, and a certain facility at understanding mathematical arguments. Thus, the proof is even accessible to an ambitious high school students. Then the author goes on to say the method of proving Gödel's theorem in this book is different from Gödel's own method. Our method relies upon elementary concepts from theory of algorithms. All of the necessary background information from this theory will be explained as needed so that the byproduct of the proof the reader will become familiar with the basic facts of the theory of algorithms. So let's go through the book. So initially they have the statement of the problem. Section 1.1 language and the alphabet. Then the set of true statements. So likewise, here there is anything unprovable. So they have explained everything, what is meant by everything, so that to get the readers get ready for the proof. So precise formulation of the incompleteness theorem, there are first attempt, second attempt, so things like that. After that, basic concepts from the theory of algorithms and the application. So there are basic concepts in algorithms, right? After that, you have some examples, so that as you can see how this book is organized. So they explain everything, the language of arithmetic, everything required to required for the proof. So it if someone is dedicated, they can go through this book and understand Gödel's incompleteness theorem. So that's it. So these are appendixes. So then there are historical remarks. So one of the truly great mathematicians of the 20th century and undoubtedly the greatest mathematical logician was Kurt Gödel. He was born in 28 April 1906 in Brno in what was Austria-Hungary and is now okay. So actually now it is called Czechia. So from the 1940s until his death on 14 January 1978, Godel worked at the Institute for Advanced Study in Princeton. So historical background is there about the Godel, and I think the period in which it was this incompleteness theorem was proved and all. So as you can see, there are exercises in the last chapter. So looks pretty interesting. So this book is under 900 pages. There are some damages. Anyway, the book is in good condition. So here you can see about the book. Few discoveries have had as much impact on our perception of human thought as Gödel's proof in 1930 that any logical system, such as the usual rules for arithmetic, must inevitably be incomplete. That is, must contain statements which are true but can never be proved. So this is about the book. So thanks for watching. This book is Gödel's Incompleteness Theorem.